this next video, our two learning objectives are accurately distinguish the difference between right triangle and oblique triangles, and next use the trigonometric functions to solve problems involving right triangles. A right triangle is a triangle that contains one angle measures 90 degrees, a right angle. This triangle has a unique property where one of its side is always the hypotenuse, which is the longest side, while the other two sides are the legs. Right triangles and fundamental trigonometry because the trigonometric functions are defined especially for right triangles. On the other hand, an oblique triangle is a right triangle that does not have a right angle in an oblique triangle. This is one example of an oblique triangle. We have here 68.5 degrees. And this is a right triangle, which one side has a measure of 90 degrees. So now that we know the difference between a right triangle and oblique triangle, let us move on to our next learning objective, which is using the trigonometric functions to solve problems involving right triangles. For example, consider a right triangle with angle theta, where the length of the side opposite to the angle is 5 units and the length of the hypotenuse is 13 units. In this case, we know the hypotenuse C is 13 and the one leg opposite is 5. The one leg opposite is 5. Solving for other leg, which is the adjacent, we have a squared plus 5 squared is equals to 13 squared. Then, a squared is equals to 5 squared is 25. And 13 squared is equals to 169. 169. So, copy the a squared is equal to transpose 169 transpose 25 minus 25. A squared 169 minus 25 is 144. To get this 2, transpose here. So, this will be square root of 144. So, a is equals to square root of 144, which is 12. So, the adjacent leg is equal to 12. So, the hypotenuse is 13. So, this is a right triangle. So, the hypotenuse is 13. And the opposite leg is 5. So, we know now that the adjacent is 12. This is now a complete right triangle.